Hey, welcome back. We've talked about vectors and scalars. At least I've talked about it earlier today. I don't know the wonder what you're watching these things. Scalars and vectors. And so again, we're using some sophisticated graphics here. And so just again, this is just vocabulary stuff. Now, vectors over here, all of these direction matter. Scalars, they don't. Now, sometimes you can't really tell the difference other than the word that's used. Now, the first two, mass and force, are very different things, although there are relationships to them, as you'll get into when we talk about Newton's second law. But mass is definitely a scalar, as we talked about in the other video. Force, direction matters, because it matters which way that a person is being pushed or pulled, or an object is being pushed or pulled, because that determines the direction it's going to accelerate, not necessarily move. Distance and displacement, they're very much similar to each other. The key here is that if I go from here to Charlotte and back, my distance I've traveled was 200 miles. My displacement, on the other hand, well, again, if you saw the other video, displacement is where are you relative to where you started. And if I end up back where I started, my displacement is 0. That becomes important when proving that I am as fast as Usain Bolt. Now, speed and velocity. Speed, that's how fast you're going. Speedometers measure speed, don't measure direction you're going in. Speed guns, radar detectors, measure speed. Velocity, on the other hand, matters when I'm trying to figure out how fast I'm going and in which direction. And that is incredibly important, again, because we're going to connect it to acceleration. Now, here's an unfortunate thing in the vocabulary here is that the scalar acceleration and the vector acceleration are the same thing. We cannot tell the difference between the two. So, however, if velocity changes, we have acceleration. Now, velocity changes means speed has changed or the direction has changed. And that becomes important because if velocity changes, that means there's acceleration. If there's acceleration, that means there's a net force. All this will become clearer as we go. And then I think the last two I have on this particular sheet, other things, energy and momentum. These are words that you probably hear a whole lot. They are math things. They are not these deep, it's not like metachlorines or things that are embodied deep inside of us. Energy is just a math thing. Momentum is just a math thing. We're going to explain that. They come straight from Newton's laws. It's a combination of the definitions of these words right here and Newton's second and third law. It'll be fun.